Okay, right. The topic that we are going to deal with is the topic of air compressors, specifically looking at reciprocating air compressors. Okay. Now, the first thing to look at is the learning outcomes. On completion of this module, the student must be able to describe solid, liquid, and gaseous fuels. Solid, liquid, and gaseous fuels. Also describe the higher and lower calorific values of fuel. Also calculate the minimum air required for complete combustion. Okay, minimum air required for complete combustion. Also calculate the products of combustion. Okay, then describe the bomb, calorimeter, and the ORSAT apparatus. Okay, right? The ORSAT apparatus. Right, now as an introduction, in this course we are going to deal with single stage reciprocating air compressors. Now here's an example of a single stage reciprocating air compressor. Okay, and it shows a reciprocating air compressor with the compressor at the top cooled by a fan, okay, and driven by an electric motor. This is mounted on the receiver bank. Okay, now the definition of an air compressor: it is a device that converts power using an electric motor, diesel or gasoline engine into potential energy stored in pressurized air. An example would be compressed air. So here's again the picture of a reciprocating air compressor. Okay, right, so now we are going to continue. We are now going to talk about the construction. A reciprocating compressor is a positive displacement compressor that uses pistons driven by a crankshaft to deliver air at high temperature, at high pressure. Okay, the intake air enters the suction manifold, then flows into the compression cylinder where it gets compressed by a piston driven in a reciprocating motion via a crankshaft, and it is then discharged. Okay, right. To continue now, there is an inlet or suction valve and a discharge valve. Both are one-way valves and both are spring-loaded, so it takes a certain amount of force to open them. The inlet valve will only let air come into the cylinder and the discharge valve will only let air out. Okay? As the piston moves downwards through the cylinder, air is sucked in the inlet valve. When the piston moves up through the cylinder, the inlet valve closes and the discharge won't open until a certain amount of force is applied. Okay, this causes air to be trapped inside while the volume is reduced, increasing the pressure. When the pressure is enough to open the discharge valve, then the air goes out at the higher pressure. Okay. Single acting cylinders, it forms part of the construction of a compressor. Single acting cylinder. A single acting cylinder is a reciprocating compressor. In a reciprocating compressor is a cylinder in which the working air acts on one side of the piston only. For one revolution of the crank, one swept volume of air is delivered. Okay, right? Something to note. Single acting reciprocating compressors only have valves on top of the cylinder. So there is one compression cycle for every turn of the crankshaft. We are continuing the cylinder. This is a metal tube shaped casing or body which is generally fitted with a metal lining called the cylinder liner. The liner is replaceable when it becomes worn and inefficient. The cylinder is also fitted with suction and discharge ports which contain special spring-loaded valves to allow air to flow in one direction only. The piston, okay? The piston consists of a metal drive rod connected to the piston head which is located inside the cylinder. The piston head is fitted with piston rings to give a seal against the cylinder lining and minimize internal leakage. The other end of the drive rod extends to the outside of the cylinder and is connected to the driver. Modern industry generally used high power electric motors and gearing to convert the rotating motion into a reciprocating action. In a single acting compressor, the backward stroke of the piston causes a suction which pulls in air through the inlet valve. The same suction action keeps the discharge valve closed. On the forward stroke, the positive pressure generated by the piston closes the inlet valve and opens the discharge valve. The air is displaced into the discharge system. Okay, now a safety warning. Because the action is positive displacement, a piston compressor can generate very high pressure and therefore must never be operated against a closed discharge system valve unless it is fitted with a safety relief system in order to prevent damage to the compressor and or the driver and or other downstream equipment. Okay, right, so over here we have what is known as a water jacket. Okay, there's a water jacket, and then over here there is a discharge valve, and then also we have an inlet valve. Then when we talk about inlet valve, it's important to note that over here you have your atmospheric pressure, okay, going in via your inlet valve. And then also when we talk about your discharge valve, we should note that this is your receiver pressure, okay. Then the body here doing the reciprocating motion, this is known as your piston. Then obviously this over here, this is known as your cylinder. And then this is your connecting rod. Then this here is what is known as your water jacket. And then here it talks about the piston travel, simply meaning the stroke. Okay, that's your stroke. And then obviously over there we also have what is known as a clearance. Okay. And then this whole configuration constitutes what we will refer to as a single acting air compressor. Okay, what we have in front of us here is a single acting air compressor showing the crank. Now when we say showing the crank, this over here is the crank, or otherwise known as the crankshaft. Okay, we have a trunk type piston, we have a crown that's indicated over there, we have a piston pin, and then we have a connecting rod over here. Okay, right. So now we are going to talk about a double acting cylinder. A double acting cylinder, as indicated in the previous sketch, it is a cylinder in which the working air acts alternately in both sides, okay, of the piston. Okay, in order to connect the piston in a double acting cylinder to an external mechanism such as a crankshaft, a hole must be fitted in one end of the cylinder for the piston rod, and this is fitted with a gland or stuffing box to prevent escape of the working air. Double acting reciprocating compressor is similar to single acting, but they have inlet and discharge valves on both sides of the cylinder. This gives you 2 compression cycles for every turn on the crankshaft. Okay, did you know double acting reciprocating are some of the most efficient compressors ever built, but they are not as common as they used to be. They are still around, but they are extremely large. You rarely see one under 100 horsepowers. Back in the days, they used to be called earth movers because being around one felt like you were in an earthquake. If the compressor didn't have the right foundation and vibration isolation, it could tear down the building if it was in. These used to be the workhorses in manufacturing plants, but in the last 20 to 30 years, that role was taken over by rotary screw compressors. Okay, right, so what we have over here is what are known as your outlet valves. Okay, let's start with the piston. There's your piston. Okay, and then over here you will have what is referred to as your outlet valves, and then over there you will have what is referred to as your inlet valves. Now when I say inlet valves, it's important to note that on top is your inlet. Okay, so that is your inlet. Okay, and then here at the bottom, this channel, this passageway, this is otherwise known as your outlet, associated with your outlet valves. Now this is a graphical demonstrative way of indicating the working principle of a double acting air compressor.